So this is the symbol of diode, where diode will have two terminals. One is anode and another one is cathode. So now we will see how to identify the terminals of diode. If you observe on the diode, every diode will contains two color. Here in this diagram we are having a diode with two colors. One is black and another one is silver. So the terminal nearer to the more colored region is positive or anode, and the other terminal will be cathode or negative. So diode can be operated in two modes. One is forward bias mode and reverse bias mode. So we will see what is this forward and reverse bias modes. For that purpose, I am going to consider one circuit. So let us consider a small circuit where diode is connected to a battery. So first diagram represent the forward bias, where positive supply of the battery is connected with the positive of the diode, and negative terminal of the battery is connected with the negative terminal of the diode. Now in forward bias, the diode will start conducting, and coming to second mode, that is reverse bias mode, the positive of the battery is connected with the negative terminal of the diode, and negative of the battery is connected with the positive terminal of the diode. So in reverse bias mode, the diode will not conduct, it will offer infinite resistance, or it will simply act as a open switch. So now we will see some of the applications of diode. The first and important application is diode can be used as switch and also a rectifier. So now we will see how diode can be used as rectifier. So we already know that rectifier is a device where it is going to convert alternating current, that is AC, to direct current, DC. So let us consider a circuit diagram where four diodes are connected in bridge manner. So let us consider this circuit where four diodes are connected. So assume that this is the first diode and second, this one is third and fourth. So now we are going to make a rectifier where AC input is converted to DC. DC in sense the two terminals are fixed all the time. So this is positive and this is negative. Here I will give input as AC. So here AC will keeps on changing its polarity. So for every 1 second it is going to change 50 times. So let us consider a case for first time. So at any instant, so this positive is connected to the rectifier circuit and this is negative is also connected to the rectifier. At this point, this diode too will accept the current because positive is connected with the positive, and finally here we will get positive. Coming to negative side, here this diode 4 will oppose the negative because this negative is going to connect with positive of the diode. So it is in the reverse bias where it will oppose the negative direction coming from the source. So at this time it will try to enter into diode 3. So here negative is connected with the negative, and here finally we will get negative, here negative here. In case 2, this will be the negative and this will be the positive. So in my case 2, negative is going to be connected with the diode 1 because they are in forward bias, and from this line we will get negative. Similarly for positive. So from this we can conclude that even though we are giving a variable current directions, ultimately we are getting fixed positive and negative terminals. So the array of 4 diodes is nothing but a rectifier. Some other example, some other applications of the diodes are LEDs, that is light emitting diodes. So this is the symbol of light emitting diode. So the main advantage of using these LEDs are they will consume only less power. Now we are going to see one more electronic device, that is transistor. To understand the working of transistor, we should consider a small scenario. Assume that this is a water tank at the top of your home or a building. Now we want to fill the water from this tank in a container. So to fill the water in this container, you should turn on the tap. So here you are giving some signal to the tap so that water from the tank will flow to the container. So whenever you are giving a tap signal or tap, whenever you are going to turn on the tap, water will flow from tank to the container. The same scenario will apply for the transistor. If you see a transistor, every transistor will have 3 terminals. One is base, middle one is base, emitter and collector. So base will act as a tap, emitter will act as a tank, and collector will acts as a container. So let us consider a small circuit where LED is connected with the battery via switch. So whenever this switch is pressed, the LED will get turned on. But coming to embedded systems or automated machines, everything should be work automatically. So here I'm using a manual effort or some force on the switch to turn on the LED. So to make it as automatic, this switch can be replaced by a transistor. So I'm replacing this switch to the transistor. So we already know that every transistor will have 3 terminals. One is emitter, base and collector. Initially the resistance between emitter and collector will be high and it will act as open switch. So the current will not flow from emitter to collector. So here I'm going to show you the equivalent diagram for the emitter and collector. So this is the equivalent diagram for the emitter and collector, means open switch. Whenever if I provide a base signal, automatically emitter and collector is going to be shorted and current starts flowing from these two terminals, and finally the bulb will get turned on. So from this circuit we can conclude that I'm using a base signal to activate this LED. So if I connect this base signal to the controller, easily controller or processor can turn on automatically with some delay, or according to the application it will turn on the light. Like that, manual efforts can be avoided or removed by using the transistors. So from this scenario we can conclude that transistor is acting as a simple switch. Whenever we supply base signal, current will start flow from emitter to collector, or otherwise it will remain open circuit. Coming to the types of transistors, we are having two types. One is NPN and another one is PNP. The main difference between NPN and PNP is, to activate NPN transistor we should give 5 volts, that means high pulse, to the base terminal so that it will get turned on, so that high or 5 volts can be obtained from the controller. So controller is programmed to generate a 5-volt pulse. That particular 5 volt pulse will be given to the base of the transistor, and finally circuit gets activated. If we use PNP transistor, PNP transistor can be activated by giving 0 volts. So the main difference between the NPN and PNP transistor is, this transistor NPN can be activated with high voltage, PNP can be activated with low. So both are opposite. According to our application, we have to select a particular transistor. Now we will see some of the applications of transistor. So from this circuit we have know that transistor can be acts as a switch, where the switch can be controlled by base terminal, and one more application of the transistor is it can be acts as amplifier, where the input signal can be amplified. Mainly transistors can be seen in sound amplifiers. So you can see this is the diagram of transistor, where it is having three terminals. One is emitter and base and collector. Now we will see a integrated circuit, that is IC. So IC is nothing but a array of transistors. There are many types of ICs are available, that means application specific IC and a normal IC. So application specific IC, in sense it will do a particular task, we cannot change that task. So ICs mainly contains thousands of transistors connected. So the size of the circuit can be reduced by using integrated circuits, that is ICs. If you use directly 1000 transistors, the circuit become complex. To avoid these kind of things, we are going to use ICs. Next we will see the relay. So relay is very similar to the transistor, but the difference between the transistor and relay is, relays can activate higher voltage devices like our home appliances which are running at 230 volts, like fan, refrigerator, television, etc. By using transistors we can activate only Low voltage devices like LEDs, maximum 20 volts it can bear, but coming to relays, they can bear up to 1000 volts also. So now we will see how relay will work. So let us consider a small circuit where a fan is connected with some. Whenever the switch is closed, the fan will get turned on. So in my first case, I'm going to give a mechanical force on the switch to turn on the fan. But coming to embedded systems and automation, we should turn on the fan automatically by taking a signal. So without touching the switch, how to turn on this fan? Simply, there is one scenario, there is one consideration. Say for example, this is a iron bar. If you place a magnet here, automatically this iron bar will come towards the magnet and switch will be closed. So here by using a magnet, I'm going to activate this switch without touching the circuit. So simply I will place a magnet here, some electromagnet. I am taking electromagnet. So if we replace this switch with transistor, transistor may get damaged because transistor can bear up to some 20 or 25 volts. But here I am using 230 volts AC. For that purpose, I am considering this scenario or circuit. So to turn on this fan, I'm using a electromagnet. So whenever I give a supply to this coil will act as magnet. At that time, this switch will be closed. Whenever I release the power supply, again the switch will get opened. So here, if I give the supply, I can turn on this fan. From this circuit, we can conclude that by using a smaller voltage, we are going to operate a higher voltage, that is 230 volts. Here this coil can be activated by using some 5 or 12 volts. So here I am going to connect a voltage source. So this voltage source is connected to the coil with the switch. So whenever this switch is closed, this particular voltage, it may be 5 volts or 12 volts, will be given to this coil, and this coil will act as a magnet, a temporary magnet. At this time, this switch will close automatically because this is an iron particle where it tries to attach with the magnet. At this instant, the power supply, that is 230 volts, will be given to this fan, and finally this will start running. So by using some smaller voltage, I'm going to turn on the higher voltage. So this switch can be also replaced by a transistor so that everything will become automated. So here I'm going to replace that switch by using a transistor. Now the base terminal of the transistor is connected with the controller. Say for example, by using the controller, I want to turn on the fan for every 1 hour. For that purpose, we have to write a small program to generate a base signal of 5 volts for every 1 hour. So this is connected with the controller. So whenever the transistor receives a base signal, automatically it will turn on this coil circuit where coil get energized and it will act as a temporary magnet, and finally the secondary circuit that is the circuit having higher voltage will be activated. Like that we can use relay for the automated systems or embedded systems. So this is how a relay looks. Here you can see 8-channel relay where we can connect maximum of 8 devices which can handle 230 to some 400 volts. So if you are having 8 devices in your home, you can control that 8 devices by using this 8-channel relay. Similarly, 4-channel relay, 2-channel relay boards are also available in the market. So according to our application, we have to select particular relay board. Now we will see one more device, that is transformer. Transformer is generally a static device which is going to transform the power. So when you open the transformer, it contains mainly two coils. One is primary and another one is secondary. So this is the symbol of transformer where the power is transformed from the first coil, that is primary coil, to the secondary coil. Coming to types of transformers, we are having some two types. One is step up transformer and step down transformer. In step up transformer, the voltage is going to be step up. Say for example, if I have given 12 volts to the step up transformer, the 12 volts will be increased to 230 volts if I use 12 by 230 step up transformer. So assume that this is a step up transformer. Here I will give 12 volts. This is a step up transformer of 12 by 230. The ratings of the transformer is denoted like this. 12 by 230 means this 12 volts can be converted into 230 volts by keeping the power constant. Similarly, step down transformer, assume the same transformer as step down. Step down. So the rating of the transformer is 230 by 12. So whenever if we given 230 volts, that 230 volts is going to be converted as 12 volts in step down transformer by keeping the power constant. So according to our application, we have to select step up or step down transformer. So if you observe the transformer, it will contain two coils with different sizes, means different number of tons of copper. Each coil is made up of using a copper wire which is wounded to a iron core. So when you take a transformer, it will contain two coils where one coil will have more number of turns and another coil will have less number of turns. So assume that the number of turns for the first coil is N1 and the second coil is N2. Then N1 will may greater than N2 or N2 may greater than N1. So if the both coil turns are equal, then the transformer is considered as ideal transformer. Now how to identify the terminals of the transformer? Assume that you are having some 230 by 12 volts transformer. Now you don't know which is primary coil and which is secondary coil. Simply connect the multimeter in resistance mode and calculate the resistance between input side and output side. You don't know which is input and output, so calculate the resistance between these two terminals and these two terminals. The coil with highest resistance is considered as primary and coil with lowest resistance is considered as secondary. Like that we can identify the terminals of the transformer. Say for example you are making a small circuit where we have to step down the voltage, means you are giving 230 volts from your socket and you want 12 volts. You have to use 230 by 12 volts transformer. So by seeing the rating we can say which is step up and which is step down. So from this rating I'm saying that it is a step down transformer. So finally here you will get 12 volts output. If you use the same transformer in reverse direction, that means 12 and 230, the voltage will be increased and the circuit will get damaged completely. So make sure that which one is primary and which one is secondary side. So by calculating the resistance of input and output, we can know which is primary and which is secondary. Say for example this is step down transformer which is 230 by 12 again. Obviously this secondary side will have lowest number of turns and primary will have highest number of turns, because whenever the length of the conductor increases, voltage also increases. Here higher voltage higher number of turns and lower voltage lower number of turns. If turns are less, resistance will be low, so that it is a secondary side we can identify. Here turns are more and resistance will also high when we calculate by using a multimeter or ohm meter. So highest resistance, highest voltage, so it is primary side. This is how you can identify the terminals of the transformer. Now we are going to see the voltage regulator. So voltage regulator is the regulator where it will regulate the voltage. Say for example your device want only 5 volts. If you connect 10 volts the device will get damaged. To avoid these kind of damages we are using a voltage regulator. So the most popular voltage regulator is 7805. 78 is the series and 05 is the voltage how much it is going to regulate. Here in this diagram it is 7805. So here this regulator can regulate up to 5 volts. Voltage regulator is having some three terminals. One is input and this is common or ground, and other one is output. From these two terminals I will give some 10 volts supply. From the output side this is common, so here I will get 5 volts. If I give 30 volts input, still I will get 5 volts. So this voltage regulator is going to regulate the voltage of the input source. So there are different types of voltage regulators are available. So this is 7805 is 5 volt regulator. If you take 7812, it can regulate up to 12 volts. Means if you give some 30 volts, you will get 12 volts as output. So these two digits will vary, 5 volts, 12 volts and 18 volts, like that. Many types of voltage regulators are available in the market. Now we are going to see one more device, that is RPS, regulated power supply. So what is RPS and what is the use of this regulated power supply? Say for example, you are making a project where your microcontroller is going to operate with 5 volts. Your microcontroller requires only 5 volts. Not only microcontroller, almost every electronic device like PC, laptop, any mobile phone, all the devices will operate at only 5 volts. But in our homes, we will get 230 volts, 230 volts AC, but we require only 5 volts DC. So how to convert this 230 volts AC to 5 volts DC? By using a device called RPS. By using RPS, we can convert this 230 volts AC to 5 volts. Not only 5 volts, it all depends upon the regulator you used. If you use 7805, you will get 5 volts DC. If you use 7812, you will get 12 volts DC. So now we are going to see the circuit of RPS. So this is the circuit of RPS. So the steps involved in converting of 230 volts AC to 5 volt DC are: first one is transforming the power, that is by using the transformer. So transformer stage or transformer step. And second one is rectification. And third one, filtration. Fourth one, voltage regulation. After that, we will get our required voltage. So here total we are having 4 steps. So in the first step, by using a step down transformer, 230 by 12 volts or some other 230 by 9 volts step down transformer, I'm going to convert the voltage first. Here this 230 volts is converted into 9 volts AC. Transformers only work with AC. So this 230 volts is converted into 9 volts by using the step down transformer. After 9 volts AC, I will place one rectifier. We already know that rectifier will convert AC to DC. After taking input from the transformer, rectifier will convert 9 volt AC to 9 volt DC. So this is rectification part. So output of the rectifier we will get 9 volt DC. So this 9 volt DC still contains some disturbances or ripples, AC ripples. These disturbances are removed by using capacitors. We already know capacitors will remove the voltage fluctuations. Capacitors will remove the disturbances in the circuit. So here By using the capacitors, the disturbances present in the output of the rectifier is removed or eliminated. Finally, here we will get, after filtration, we will get pure 9 volt DC, pure 9 volt DC. This 9 volt DC is given to 7805, where this 9 volt is converted into 5 volts. Here I used a voltage regulator of 7805, so it can regulate 5 volts. Finally, we will get 5 volts output. Like that, we can convert 230 volts AC to 5 volts DC for our devices. Here you can place a capacitor which is a protecting or voltage fluctuation removing capacitor. So all these things are kept in one circuit, and we are calling that circuit as RPS, that is regulated power supply.